Hello all, and thanks very much for joining us on today's webinar. We'll be talking about how we can use simulation during the injection molding process and what those benefits are. Just by way of short introductions, I'm Rob Shropshire and I lead the sales and marketing side of Origin. Won't be doing a lot of the talking during today's session apart from a short introduction, but I will be your contact moving forward should you be interested in chatting with us further. Really pleased to be joined by Tim Dukes today, who is a co-director of Origin and is our subject matter expert. He's been working within the manufacturing space for about 10 years now and leads things all product related, as well as providing the training and support to many of our customers. So quick agenda, I'll plan to keep the introduction relatively short. You obviously want to see the demo, but I do think it's important to set some context in terms of why we exist and what we're seeing in the industry, particularly in terms of simulation and what we think the benefits are in terms of using it earlier on in the design process and what those potential barriers are. I'll then pass them to Tim, who will discuss what Altair Inspire Mold is and what types of challenges it helps injection molding companies solve. And we'll then move on to provide a high-level demonstration of how the solution works. Now, after the event, we will be offering a trial and some support if anyone does want to try it out and see how it might benefit their business. We do prefer that the session is interactive, so please feel free to ask questions as we go, and we'll make sure we get to them towards the end. So who are Origin? Well, we've got around 200 customers, all of whom are in the manufacturing space. I think what's unique about Origin is that we are focused on design and manufacturing engineers and really advocate for simulation much earlier on in that design process. So, you know, we understand that perhaps most companies will do simulation towards the end of a process or might even outsource it. But in our view, many are leaving money on the table by not doing it much earlier. Simulation, in our view, shouldn't be left completely to the domain of CAE experts, when actually empowering designers with easy to use tools can improve cross-team collaboration and also help designers make better decisions, both in terms of design and potentially material choices. As well as providing the software, we also provide local support and training services right here in the UK. And the product that we'll be presenting today is from Altair. We're really proud to be one of their UK partners. So when we sort of look at what technology we want to provide to our customers, we do like to make sure that it requires a minimal level of investment to get started with and has a relatively low learning curve. The reason for that is that we know we're in a world where engineers have to be able to often use a variety of CAD and simulation solutions. So we're conscious that a product must be able to deliver that return on investment relatively quickly, especially when there's lots of other solutions out there which will be competing for budget, you know, not just in terms of software, but also looking at the hardware side of things, machinery, scanners, all of that sort of thing as well. So as I said, we believe simulations should be incorporated much earlier in your design workflow. The benefits are clear, but not many companies seem to actually be doing it. And we'll share some research over the next couple of slides to try and unpick why that is and to try and prove what the benefits are in terms of doing it earlier. By allowing simulation to be done earlier, design engineers can explore multiple concepts very quickly. Perhaps they want to assess how a particular material might behave. Maybe they can pick a cheaper alternative while still being able to deliver similar characteristics. When they're designing their molds, if they know how it's going to fill, if they know whether there's going to be any sink marks or warpage on their part, they can adjust their designs accordingly and avoid the cost of defects downstream. If they're doing proper analysis, they can also potentially reduce the amount of prototypes they have to go through by just limiting it to the designs that they're fairly confident will work. Another interesting idea, which I'm passionate about, is simply being better than your competition. So, you know, if you are an organisation that's designing parts or molds or tooling, and you're trying to win some work, and your competitor is bidding on that same piece of work, are they going to pick the company that's able to back up their design with simulation, or provide some recommendations based on simulation, or just the company which talks about how much engineering experience they've got amongst their team? So our partner Altair did some work with Engineeringcom, who conducted an independent research report where they actually went out and spoke to a lot of manufacturing companies like you to understand a little bit more about how simulation solutions are currently being used, and perhaps why more companies aren't using them. So to kick things off, let's look at the current situation on the left-hand side there. Only 17% of organizations are using dedicated simulation tools, which isn't very high in my opinion. And 14% just don't bother, and they leave it up to pure trial and error or experience. Perhaps more interesting on the right hand side is the stage in which people actually use simulation technology, and nearly half of companies just use simulation when something breaks. So, you know, the obvious thing there is, isn't that a little bit late? What's the cost of this? A production run that goes completely wrong is probably a lot more expensive than just investing in simulation and doing it earlier. And less than 40% are actually doing that and doing simulation within the design phase. So I guess what we want for our customers is that they don't go and produce, you know, a single part or mold or tool or prototype before they've actually gone and done this simulation, to try and avoid some of that wasted time and of course money. So let's look at the anticipated benefits, so what they thought they'd get before they invested in simulation products. Most of the time they are trying to reduce part and tooling costs, as well as speed up production and increase the quality through reducing those defects. On the right hand side, you're sort of seeing what people actually realized after using the simulation software. So over half are reporting reduction in cost. Other interesting benefits are a faster time to market, which I would imagine keeps their customers very happy, and might allow them to beat the competition to market in terms of new products. And obviously having higher yields and reduced downtime means more things are being produced, and naturally more production typically means more revenue for the business. So the benefits are clear. Why aren't companies doing it more? Well, most think it's too expensive for them, and perhaps that's true. You know, certainly it would have been, you know, years ago, but technology has changed, and of course it does depend on what the solution costs and what you think the time savings might be. Many companies, they do simulation, but they just pay an external party to do that and outsource that. So depending on the amount of time that takes in terms of collaborating with that third party, or the frequency at which you're paying for those simulations, there might be a saving there to bring that in-house. Now, lack of training is a really important one. It's not surprising that businesses are a little bit suspicious in terms of investing in something and then staff not actually using it. We're all operating at 100 miles an hour, and sitting down to learn a product means that you're not doing your day job, and that's why you should work with companies like Origin, who can not only provide a trial to make sure the product fits with your requirements, but can also provide training and ongoing support to make sure that you get ramped up relatively quickly and get that return on investment. The 20% of people that just don't bother, or just use gut feel, I mean, in my humble opinion, simulation-driven design is just the next step in how the industry is evolving. You know, trying to deliver more efficiency in a world where we keep talking about how margins are getting squeezed and competition keeps getting tougher. So how are we looking to differentiate ourselves amongst that competition? And we think simulation earlier is a way to do that. Now, on the right hand side, you can see the issues that I guess, keep manufacturing companies up at night. And most of them, it's about reducing the cost of tooling and parts, along with delays in getting products to market. And as we've literally just spoke about on a few slides ago, simulation software is allowing businesses to solve those challenges. So it really should be looked at seriously. So, you know, hopefully I've managed to persuade you in the last couple of slides that simulation earlier on in the design process is at least worth considering, at least having a conversation with your peers and management team. So I'll now pass over to Tim to get into the specifics of what the Inspire Mold product is. So Tim, over to you.
Simulation driven design. Let me share my screen. And I'll be going through the Inspire Mold solution. So first of all, the Inspire Mold solution is like it sits on a platform of Altair Inspire products. And you can see here a number of them. Just to go through a couple of them, you've got Inspire Studio, which is like an initial design / rendering tool. You've got the Altair Inspire tool, which is a topology optimization tool, and also FEA. Another few tools are Inspire Cast, Metal Flow, Injection Molding, which is the one that we're looking at today, Inspire Mold. You've got Inspire Form for metal stamping or metal forming. You've got Inspire Extrude, which fits into polymer flow, polymer extrusion or metal extrusion. And you've also got Inspire Additive, which is metal 3D printing. So that's where the Inspire Mold tool sits, and this is sort of what we call like a manufacturing suite of products. So most of you will be aware of probably what injection molding is, but for anyone who isn't, I'm just going to just play a very, very short video just so you get an idea of the injection molding process, and this will just hopefully explain what injection molding is. So injection molding is basically a very, very simplified version. Is plastic pellets or granules are fed into a screw, fed into the screw, and they are melted, and then they are injected into the cavity or the mold tool at high pressure. The mold tool is then cooled, and the part is then cooled. The mold tool will then separate. The part is ejected, and then generally the process is repeated. So this video hopefully shows that. In this mold tool, we can also see some cooling lines that obviously aid in the cooling of the part. Injection molding is one of the sort of most common and versatile sort of manufacturing operations. It allows you to produce. Oh, I've gone too far. Never mind. It's one of the most complex, common and versatile operations for mass production of complex sort of plastic parts. The nice things about it is you can get parts with excellent sort of dimensional tolerance, and it also generally requires either minimal or no machining after the molding operation. So what is Inspire Mold? Inspire Mold is an analysis tool for the virtual testing, the validation, and the correction and optimization of molding designs. We like to think that Inspire Mold has got fast onboarding, and it's got a really nice licensing model. So we think Inspire Mold is fast, easy, accurate, and affordable. A lot of people think that simulation, previously we see this a lot, where people think that simulation is either expenses, as Rob has just previously mentioned, or it's too complicated. So we think Inspire Mold sort of solves these problems. One, the licensing model is very, very good. It's a cloud-based licensing. The software is hosted locally, but the actual licensing is cloud-based, and I'll go through the licensing when we look at the live demo. Easy to use. We generally think that you could get up to speed with Inspire Mold with just 1 day of initial training. And this is down to a very easy 5-step workflow, which we'll look at when we go into a live demo. And the 5-step workflow will be covered in a separate slide. So how does Inspire Mold work? Well, you basically import a 3D CAD model. Doesn't really matter where the CAD model comes from. We can import a number of different formats. The software will then turn this CAD model into a mesh, and on the right hand side you will see a model. This is from Inspire Mold, and you'll see the actual mesh, and these are like small triangles, and the software will basically run calculations on each of these individual elements or triangles to get the results. And that's a very simplified version, but that's in essence what is happening behind the scenes. So it's a state-of-the-art biphasic finite element formulation. So this allows you to capture the filling process and the cooling process with great precision. The software will automatically create the mesh. So this means you don't have to be a simulation expert. A lot of people think meshing is complex. You have to know where to apply certain sizes, faces and things need to be certain different sizes. But this isn't the case with Inspire Mold. You have control over the mesh in terms of the mesh size, and generally this is done on, if you want to do a fast analysis, you'd have a larger mesh size. If you want to do a more detailed analysis with maybe more processes such as packing and cooling, you might do a smaller mesh size to get higher accuracy results. So so the meshing isn't complicated, and we'll see that shortly. This is the 5-step workflow. So the step 1, and this is a screen grab taken from Inspire Mold, so you'll be familiar with this when we go through the live demo. But the first step is, and you always work left to right, so you can see here these steps in the images here. First step is to basically select your part or your part cavity and designate a material. Second step is to designate or add a gating system, so you can add your gate, your runners, your sprues. Third step is to designate or create any components. These can be cooling lines, the actual mold tool. Fourth step is to set up the process. So depending on what process you're running, whether it's filling, you could set up filling time and other things. And then the fifth step is just to run and analyze and hopefully get some results. So why use Inspire Mold? The main reason to use any simulation or analysis tool is to potentially, hopefully, remove defects or problems before manufacture. So you can see a few of the standard common sort of injection molded defects here: sink marks, welded lines, air traps, or warpage. And so one of the most common uses of a simulation tool is to try and mitigate or reduce those defects before manufacture. Obviously, mold tools are expensive. The last thing you want to do is go and manufacture a mold tool and then find out that it's giving you bad or rubbish parts. So that's the last thing you want to do. Another reason you might use Inspire Mold is to actually sort of guide you on the best sort of method. So gating locations, the best place to put cooling lines and stuff like that. So it can actually guide you on how to actually build your actual mold tool as well. Lastly, you may use it to maybe remake existing mold tools. You might want to optimize an existing mold tool. So you might want to run it through an analysis tools. Maybe you are getting issues with parts that you haven't run analysis on. So you might want to actually run an existing mold through the software to see if you can improve on the design. So what are the outcomes of using Inspire Mold? So hopefully we're going to be able to study all the stages of the injection molding process, from filling to packing to cooling and actually the warpage of the part, and to identify defects such as the ones we saw earlier, and obviously more. So these are sort of the important questions. Anyone who's involved in injection molding, these are sort of the questions you'll probably ask yourself whenever you actually get a part or get sent a part. Just basically, can this part fill? Where is the best gate position? What happens if I change the material? The position of weld lines, location of air traps. Is there a risk of sink marks? Are the wall thicknesses okay? Deformation of the product. if it deforms, is it no longer fit for purpose? Cycle time, hot or cold runner, and runner balancing. And these are all the questions that hopefully Inspire Mold will allow you to answer. So that's just a bit of an intro into the demo now, and hopefully you're seeing the Inspire Mold sort of user interface. Very first of all, I'm just going to just quickly run through the user interface just so you get a bit of an idea on how this sort of works. Quite a clean user interface, quite a user-friendly interface. We like to think it's quite modern, so hopefully it looks fairly clean. We're in the molding tab at the moment. This is the tab, obviously, that will set up our injection molded process. And hopefully here you can see the 5-step workflow that we mentioned earlier. So you always work from left to right, and we'll go through that shortly. Just to go through the tabs, we've got the geometry tab, so we can obviously modify and create geometry within Inspire Mold. It isn't designed as a CAD tool, but you are able to import 3D models and make modifications to them, which we'll see in a minute. A lot of the time that might just making small edits to models, creating a method, maybe simplifying models to defeature and things that maybe are going to be added after the molding process. So those are tools that allow you to do that. Then we've got our sketch tab, fairly straightforward, allows you to create your sketches that you will hopefully be familiar with, lines, arcs, circles, rectangles, and all that sort of stuff. And obviously you can add dimensions to be precise. The view tab is just what you are actually seeing in the program. So I like to have my model browser on, that's why it's ticked, and the model browser is this here. And that will just show my assembly structure or my component structure as I create things. Edit is your window shortcuts. So if you are familiar with the window shortcuts, that'll be fairly straightforward. And then file, obviously similar in 90% of softwares. So the file allows you to open and save files straightforward. In here we do have direct links to all the help files, screen capturing so you can take snapshots and videos, and also the licensing. So obviously we did mention briefly the licensing, which is cloud-based, which we think is very good, but the software is local and all your files are stored locally. One of the nice thing about the license is you can take the license offline. So if you want to grab the license and maybe go off site where you might not have internet access, and you want to be able to show your customer files or whatever, you can take the license offline without internet access. Another nice thing for that is potentially if you are running a simulation overnight, you want to make sure you don't lose connection to the internet, which sometimes does happen. You can always take the license offline and run a simulation overnight, and you're not going to lose that connection. So that's the user interface. You've got your sort of view controls down here in the left hand corner, and then your units in the right hand corner. So I've set mine to manufacturing millimeters, but you can set them to any units that you like. And so first of all, I'm just going to literally bring in a model. So I'm going to open a model just to first go through the file types we can open. We can open up all your neutral file types, your steps, your ASIS, your IGES file types. But then we can also open up your native CAD file types as well, like CATIA, Inventor, SolidWorks. So you'll hopefully be able to import a model regardless of who's created it or where it's come from. So I'm just going to open up a file, and I'm going to open up a Parasolid file. So this is just a single part, got no sort of method or any other components attached to it. And we're going to just show you a few of the sketch and geometry tools first of all. So in this model, if I look at it, analyze it, I can see there's an area where this sort of clip is here, where there's no cut through on the opposite side. So I might want to just punch through a hole there. So we can use our sketch tools to do that. In this instance, I'm going to use my rectangle tool. I'm going to put my sketch grid on this face, and then I'm going to just create a very quick sketch. We can obviously be precise and actually add dimensions. So we can always use our dimension tool to control this. But I'm just going to just eyeball it for the purpose of the demo, and then go into my geometry tab. I'll have a surface there now, which hopefully I can use the extrude tool to select on. I want to do a subtract, and I want to go in the negative direction. So I want to click this plus minus or reverse the direction. I can keep it as mine 10 mil, as I know that will be more than the thickness. And then if I'm happy with that, I can just hit the tick box here, and we should now have a hole through the model, which I may have missed that. Let's just do that again. Make sure I do a subtract in the negative. There we go. So now we've got a hole in the part. Another thing that we may want to do in the geometry tab is potentially, again, you might have some features that are machined afterwards, potentially holes and stuff. Threaded holes might be machined afterwards. So maybe these holes are going to be machined afterwards. So I'm going to remove them. So I'm going to use the simplify tool. Here we have a number of options. One of them is to find and remove holes. So it's found all the holes in the model. I don't want to get rid of them all, but in this instance, I just want to manually go through and click on these 4 holes. So that's my holes removed. So I'm basically just prepping my model, and now it's ready to start the injection molding process. So now if I move to my molding tab, this will start our sort of 5-step workflow. The first step is to designate the part. Well, this would obviously represent the cavity in the mold. And here we can see the materials that we can use. So we can just show you, we've got different types of plastic, all the different types of polymers, and then the different grades for them as well. So hopefully you'll be familiar with a few of those. And then on the right hand side, this is the initial temperature of the material. So if your material isn't there, we can import materials, we can create your own materials, we can edit already preset materials. So those are all your options, and these are your material properties. So you can have, obviously, for different materials, we'll have different properties. So lots of options in terms of material creation and selection. For the purpose of this demo, I'm just going to keep it as a default material and accept that. We can use this tool here to reorientate the cavity, so we can change the direction of the mold. And then we would just specify a face, and that would just reorientate the cavity. Moving to the right, we'll go into the runner system, and in this instance, I'm literally just going to add a single gate to the model. I'm going to add a single gate by clicking on this tool and then specifying on the model where I wish to add that gate. In this model, I'm going to add it to this face here. I can modify the dimension of that gate, so I'm going to change it to 1.8 and right click to confirm. So we've added our gate. I'm not going to add any more runner tools for this because I just want to do a quick fill-in analysis of the part fill-in with this gate location. We can have multiple gates. Obviously, certain parts will have multiple gates, but in this instance, I'm just going to keep it as one gate, fill in from there, and I want to see how the part fills. Just to move, going to the left to the right, tooling. If you want to add vents, molds, other components, we can do that in the tooling section, which we'll look at later. And then you've got your process parameters. So you've got your different processes: filling, packing, and cooling. And for each of those, you've got different settings. So I'm going to only be doing a filling process at the moment, and I'll just leave the settings as the default. I can click on the run analysis tool now, and this is your mesh settings. So this is your mesh settings. We can see here that we've got fast or detailed. For initial filling analysis, I just want to do a very fast analysis. And what we looked at in one of the previous slides earlier was when the part meshes, it turns into obviously a triangulated mesh. And this is your element size. So as I slide this bar to the detailed, we can see our element size decreasing. And if you go into the detailed analysis, you can do more simulations such as packing and cooling and warpage. I'm going to keep it as a fast, as I only want to do a filling analysis. We can obviously modify these ourselves, and we can specify the number of layers. A general rule of thumb is you want at least 2 layers on. If there's a wall thickness, you want at least two elements in a wall thickness. I'm going to click the run tool now. And just to explain what's happening here, the initial thing that's happening is the software is converting the 3D CAD model into a mesh. So you can see the stages that we're in at the moment. We're in the meshing stage. So it's converting that 3D model into that triangulated mesh. Once it's completed that, it will go into the filling stage, and obviously that's the only stage we're doing. If you did multi-stages, it'd go from the filling stage to the packing, to the cooling, and then finally the warpage. So we're in the meshing stage. It will move on into the filling stage in a minute, and we are going to do this live just to show you sort of the speed of the solvers, and this allows you to obviously investigate different concepts very, very quickly. So I can investigate different gate locations and find the most optimum one to fill, optimal area to fill from quite easily. So it's filling now. While that's filling, I'll just sort of explain potentially what we're looking for here. In this model, there might be a high load on this area here where this sort of cylindrical area is here. So that might be where there's a connection point, and that might be a high area of stress. So if we are seeing defects in these areas, that might be an issue. So we might want to not see any defects. If we are going to see any defects, the last place we want them to be is these, as it might compromise the performance of the part. Another nice thing about Inspire Mold is obviously while this is filling, we can sort of hover over it, we can see the percentage it's filled, and at any stage we can click on the actual results and we can click view now, so we can view the results midway through the simulation. So I'm going to click view now, and we can see sort of how much of the part has filled. On the bottom here, this is sort of our animation tool. These are your animation settings. I always like to sort of decrease my speed, make it a little bit slower. So we can drag that slider bar to the left-hand side, and there are other settings here that you can use. Just to drag this back to the start, we can then hit the play button and watch how the part is filling. So that's how the part is filling so far. One thing obviously initially I note is as this part fills, we are getting two sort of fronts of material sort of meeting. Generally when that happens, especially when we've got different temperatures meeting, you might get obviously sort of a defect in that area. We may see a sort of a weld front. So initially straight away I can see that from the analysis. On the right hand side, this is our different results that we can sort of explore. I've just noticed the simulation is completed because we've got this little red flag, so I'm going to load the full results and then we'll go through them. So let's just first of all play the analysis. Let's play the simulation and see how it fills. We are just looking at the temperature evolution as it fills at the moment. So you can see on the right hand side, we're just looking at temperature at the moment. So we can see how the part fills. That's how it's filled. We are looking at temperature at the moment, but just to go through other results that we can look at in the filling stage. Obviously, more results will become available in different stages. We can look at velocity, pressure, filling time, air traps, weld lines, and thickness, that sort of stuff. So things that obviously might be useful. Let's just look at pressure. And we can see how the again the pressure evolves as it fills. What we can also do is we can also add call outs. So we can see here we can create a call out. Potentially I might add a call out on the gate. Let's just add a call out there. We can again hit that play button and we can see the pressure change as it fills. Another nice thing though is we can use this tool here to plot a graph. So if we click this tool here, we can now see our results plot, and we can see how that pressure changes over time. If you use this slider bar, you can actually slide it back to any point or any time within the filling, so you can use that and hold it on a position. So that's quite a nice thing. Obviously, this results plot can show anything, so you can look at different values. And let's close that down. One thing obviously we were interested in, and we did see as the part was filling, was the weld front. So we'll look at the weld lines, and we can see here clearly there is quite a big weld line in this area, which may be of concern. It may actually affect the performance of the part because that is a critical area. So so that might be something we want to get rid of. So maybe where I filled that from might not be the optimal location. So we can very quickly just create another gate, and let's refill it. So I'll click this tool to go back to the CAD model. Another thing I'll just quickly show you here is let's just show temperature. We can show the mesh. So this is the mesh at the moment based on the fast filling. So we can see our mesh density and our mesh size, and that's based on obviously the sort of higher mesh size because we're doing a fast solve. So that's how we can actually physically view the mesh, and we can view the parts. So we've got a number of options in terms of viewing. I'm just going to remove this gate now. So I'm going to actually delete this gate just by selecting on it, hitting the delete key, and we can literally very quickly just create another gate. So maybe a better location to fill this part might be somewhere else. Maybe I'm going to try and fill it from maybe the center of here. And again, I'm just going to just create one. We can always reposition this. Obviously, we're just sort of eyeballing it, but we can reposition this using your move tool. So maybe I'm happy with it there. I click accept, and then I'd run another analysis. So rather than again waiting 2 minutes until we get some results, obviously it is quite quick, but for the purpose of the demo, we want to get through as much as possible. I'll do this sort of Blue Peter style where I have created one that I did earlier. So let's say don't save, and this will be the change gates. So in this model, we can see the gate location is as such, and if I click on this tool here, because I've already ran it previously, we've got some results. So again, let's just watch how the part fills. So we can see how the part fills, and again, we're just looking at temperature evolution. Let's obviously one thing we were keen on was to look at was the weld lines, and we can see obviously where those two flow fronts meet. We are getting weld lines on that side, so we maybe would try and remove those. But one thing we can see is we have removed them from this area here, so maybe a slightly better filling location in terms of this critical area is no longer getting any weld lines or defects. So maybe that's one good thing, but obviously again we have to just sort of move the weld line to another area. So that's just a quick demo showing you how quickly you can run and set up an analysis, and how you can just explore multiple gating locations very, very quickly, and hopefully find the optimal one. What we're going to look at now is just a few more of the process setup. So let's just turn off the results and go through the process setup. So working again from left to right, we've already set up our part material, and the next step would be to specify a runner system. So we've already added a gate. We might want to add a runner system. If we click the runner, create runner, generally, or sometimes you might have multi-cavity molds. So if you've got a 4-cavity mold or more, you can specify the number of cavities or parts you have in your mold. So you can see here, we can click the drop down, and I can say I've got 4-part cavity. These are all parameters that we can obviously modify, and then we can hit the create tool, and this will very quickly create a 4-part mold. So if you are filling a 4-part mold, obviously you'd want to simulate that, and we can see here how we've created the gate, the runner system, and the sprue. We can change all those options. So if I click this tool here, all these can be changed, and I'll just quickly change a couple of these just to show you how you can obviously modify it. I'm going to basically change the distance between the parts, and maybe the distance between the runners. So let's just update these to 20, just to show you this changing. And let's just do the same for that one. So hopefully you can see there, just the distance has increased ever so slightly. So all these things are editable, and you can modify these to suit. So that's your allows you to create multi-cavity molds. Again, we can just quickly view a simulation how this filled. So let me just open up the results. And again, this is just purely filling analysis at the moment, but we will start to look at some detailed analysis later on. Click the results, and these are preloaded, so we can we're going to just view a video, just view the animation, how this part fills, how this mold fills. So we can see the time it takes for the 4-part mold to fill is down here. So we can obviously view all that sort of stuff, and then you can look for any defects and that you may get using your results explorer. So that's just a quick example of a multi-part mold, multi-cavity mold. One thing that's quite important in injection molding is venting. Venting is generally done near split lines, but the Inspire, what you'll notice, I haven't actually created any venting when I was doing these quick filling analysis, because the software will automatically assume venting if you don't manually apply it. And I've got a good example of this. If I just open up a part, so a fairly straightforward part, but you may notice these little red dots on the left hand side. So what that actually is I've added a vent. So you can add vents to your model using the tooling section, and we can specify vents. And to add a vent, it's literally a matter of either, if you want to apply a vent to a whole edge, you can double click, or if you want to apply a vent to a certain location, you can just click and drag, and you can just apply a vent to a certain location. So if you are getting air traps in a certain location, that may be where you want to apply a vent. Let's just delete those two. So that's how you actually create the vents. In this example, I've run two analyses, one where I've only applied a vent to one side, and the first analysis I didn't apply any vents. I just let the software assume venting. So if I click the Analyze tool, let's go to the first one first, and we can play the analysis, play the simulation, and we can see how this part fills. So it fills as we'd expect. So it is automatically assuming sort of venting in these areas. If you manually apply your vents, and we play the simulation, and I've only got a vent on this left-hand side in this instance, we can see as the part fills, this is what we're ending up with. So obviously, because of the air entrapment in this area, the part can no longer fill, and it stops filling. So we don't get the actual full part. So obviously that shows you the importance and shows you what is happening in the software. Obviously, manual vents are needed in some cases. Obviously, if you are getting air entrapments, you want to add those manual vents to draw out that air, and obviously allow the part to fill. So that's just a quick example of venting, which is obviously very important in injection molding. Another thing that I'll quickly want to show you before we get on to the detailed analysis is how, if you've already got a method, so if you're more comfortable setting up maybe the whole method in your CAD system, so you've created your cooling lines, you've created your part with your runner system and all that sort of thing, you can obviously import that into Inspire Mold and designate components as things. So if we just open up a CAD file, it's going to be the same one, but this has obviously already got a system or a method added to it. So it's just a few things, so we can see that we've got a runner system and we've got a cooling line. So fairly straightforward. And the way that this would work is we've got two options. So this tool obviously allows us to designate the part cavity, which would be this, but there's also a tool to auto configure components. So what this will do is it will auto configure the part and the runner system. So if I click this tool here, select the inlet to define the part cavities. So I need to select where the obviously material is flowing in from, the inlet, and that be that face there. And instantly we can see that it's designated the part cavity, it's created a gate, created a runner system and a sprue. Hasn't designated the cooling lines, I will need to do that manually. But here we can now set the material, Let's use a different material, nylon of some sort, and accept that. So that's the auto configure tool, which is quite a nice tool in Inspire Mold, and it is quite intelligent, and it will find your runner systems and gates. If I want to designate my cooling line, I can go to my tooling tab. Obviously, what am I at looking for? A cooler. And this little tool here, on any of these, if you ever see this tool, it allows you to designate a part. So this is my my cooling line. Here we can specify whether it's a fluid or a gas, and then we can specify a temperature. So we can obviously change that. And then if you're happy with it, you can right click to confirm it. So that's how you designate components if you have already created your method in your CAD system. If you, just to show you how you actually create a cooling line within the Inspire Mold system, let's just right click and delete this one first of all. And click on cooler. So first we need to define a mold. So I'm going to click that tool there. When you define a mold, you can specify the mold material and again the mold temperature. And then we can always bring the top face down to obviously where the inlet would be. Now that I've done that, I should be able to create a cooling line. And just a very quick example of this is you basically just tracing a path of the cooling line. So I won't do this too good, but let's just draw a simple path as such. So that's just a simple cooling line. I can then specify the cooling line diameter. So we can see that here. Again, the temperature and the gas or fluid. And you can use the move tool to move it into position. So if you're not happy with it there, we can use the move tool to move it into the position that you need it. You can also use geometry tools to extend them and all that sort of stuff. So you can use the pull tool just to extend them if you want to extend them further. So I'm happy with that. Right click to confirm, and that's my my cooling line created. So the next thing, I'm not going to run an analysis on this, but we're going to start to look at the detailed analysis now. So we're going to look at some different processes. In this instance, we're going to be looking at the packing, the filling, the packing, the cooling, and the warpage analysis. So certain defects we know will only appear in certain stages. Obviously, we have to let the part cool to be able to see potentially the warpage or the deformation. In the packing stage, that's generally where you might start to see sink marks appear. So certain defects will only be able to actually physically show if we run those processes. Detailed analysis will take longer because obviously you are running more stages. You might be running 4 stages, so we could potentially be running, filling, packing, cooling, and a warpage stage. So it is going to take longer, and generally we would do this at a finer mesh. So you would reduce the mesh size. So it is going to take longer. So I'm not going to be able to run those analysis live on the demo, but I've got some results to obviously show you. But obviously you want to run that at more detailed, higher accuracy because we are gaining a lot more information from those results. So the setup for running a detailed analysis would be exactly the same. You can add as many components as you want and set up your process parameters. Obviously here we could set up our packing and our cooling parameters. So we can set all those up. And if you've got machine parameters as well, you can set those up as well. So let me bring in a file with some results. Let's just so I'm going to just show a file with some filling and packing results. So I'm going to click the tool here. In the filling stage, because we've now got a mold tool, one new thing that we can see is the mold temperature in the filling stage. So we can obviously view that mold temperature. I have actually got a split plane on this, so we can create section views. So you can see I've got this section plane here that can be turned on and off, and you can obviously create multiple section planes. But again, you can see the temperature of the mold as the part fills. So obviously just in the first 1.3 seconds. But in this instance, we're going to look into the packing stage. So this is a stage that we haven't seen yet, and this is the packing stage. Again, we're just looking at the mold temperature in this stage, but you might want to look at the temperature of the part. In the packing stage, things that might be important are pressure. So you can find out the required pressure in this stage, in the packing stage. We can use the the call outs and things to apply to get measurements. So that's the packing stage. Obviously, another thing that we can see in the packing stage is sink marks. So if I click on the sink marks tool, this will identify on the model where areas where we may get sink marks, and then you potentially might be looking at things like wall thicknesses. So we can see here straight away we are going to get a sink mark potentially in this area. That may have, in this instance, I haven't filled in these holes. Maybe that would have been negated if I had filled in those holes. So that's something obviously to be wary of. Simplify your models first, but you might be again looking at potential wall thicknesses and areas to try and remove any sink marks. And for the sink marks, obviously we are just getting a measurement value on the sort of the depth of that sink mark, so we can see that on the right hand side. And again, we can put out call outs and we can find out the value of the sink marks in any location. So obviously you won't be able to see those in the filling stage. That's just again showing you some more detailed analysis. Let's open up a cooling and warpage analysis and click the results button. So in the cooling stage we're looking at now, we might look at obviously the temperature evolution again as it cools, and we can see how long it's taken. In this instance, it's taken 49.5 seconds to get to the required temperature. So we can see that. Again, we can look at things like mold temperature, and obviously in our demo we've only put cooling lines. We can see the effect of those cooling lines on the actual mold on the part. So in real life you probably wouldn't have the cooling lines just at the top. We might want them also on the underside, but we can clearly see the effect those cooling lines are having on the mold just by having them at the top. So you can see here it's obviously a much cooler mold at the top because of those cooling lines. So so that's something obviously we can use the software for. The last stage we'll be looking at today is the warpage stage. So we can see how much our part deforms. So deformation or displacement, we can see how much the part deforms. One quite cool feature on this is obviously we can put call outs, and we can put call outs anywhere on the model. If I add a measurement, let's just do it, just eyeball a sort of a measurement on this model. Let's just do something. Again, this isn't very accurate, but what we can do is we can see that how much the part sort of deforms as it cools. So I've just added a simple measurement there, obviously not straight, but you get the idea. You can see here this part is cooling or shrinking by like 0.1 of a mil. 0.1 of a mil, and again, if the part is deforming maybe past tolerance, that's obviously something that you'd want to account for in the design. So that's something you can check for. So that's just a quick demo of the Inspire Mold software. So first of all, thanks for taking your time to obviously watch the demo. If you've got any questions, or if you've put any questions in the chat box, this is the time we'll answer them, and I'll just pass back over to Rob now.
So yeah, thanks for attending. You know, Tim's given you hopefully a relatively comprehensive demo there. Hopefully you can see it's you know, relatively easy to use. Of course, we'd love to spend more time with you if you've got you know, a specific use case or something you'd like us to explore using the software. We can certainly accommodate that. And as I said, offering a free trial and giving you the chance to test that out and giving you some complimentary consultancy alongside that might help you to understand a bit more how it might benefit you, or if you are already using something, how it might compare to a package you might already be using. And yeah, finally, happy to help you you know, build a business case. I think with a lot of these things, engineers doing things day in, day out often like the idea of this technology, but how can you monetize that and get the buy-in from the management team? So we can certainly help to support that. There are a few questions that have come in, Tim. Just while we take a couple of questions, I'll just leave our details up there. So if you do want to drop one of us an email or give us a call, we can certainly we'd love to speak to you. So a few questions that have come in. A popular one, which is really how it compares to other products. I think Moldex and Mold Flow has been listed here. So I guess I'll kick that off to start, and then Tim maybe add if you can. But I think Altair Inspire Mold, it's fair to say, is a slightly newer product than Moldex and Mold Flow, which in their own right are very powerful. I think what Altair Inspire Mold offers, hopefully, is a very nice user interface. We think it's very easy to use, and certainly the feedback that we're getting is that it is easier to get your head around compared to some of the other packages out there. I think also remember what we're targeting here. So we are targeting simulation at the design stage, and being able to quickly run simulations. So we think that this product is absolutely perfect for that. Also the ability to do more detailed analysis as well. And typically we often get feedback on the price point, to be completely honest. So usually we are quite a bit cheaper. So if you are perhaps renewing annually with whatever you've already bought, or perhaps you've not actually invested in simulation software before and you're trying to dip your toes in and prove that case out, and this product hopefully will be perfect for you. Tim, have you got anything else to add, or have I sort of covered most of that?
Yeah, I think that's most of the point. Yeah, easy to use, minimal training, and a lot of the time does everything you want it to. Sometimes with additional products, I think there are sometimes additional features that you might not use, and you aren't getting maybe as much value for money. But yeah, again, there's benefits to different tools.
Cheers. Tim, I will let you lead this one because you deliver most of the training, but it's just asking what our general approach is, to training. Presumably, do we do it on site? Do we do it remotely? How often? How long do we usually recommend in terms of getting people up to speed?
Yeah, so we do like to think that generally, hopefully you saw there the simplicity of the product. We like to think a day on site, that would generally get you up to speed and hopefully allow you to use the software on your own, obviously with our support afterwards. But yeah, generally a day's training that we like to deliver on site, but obviously we're aware of the times now. We're happy to do that, split that into multiple hour sessions as well. So we personally deliver web training and on-site training.
Thanks, Tim. And yeah, this is just another question just to go over the licensing approach once again. Yeah, Tim alluded to it. It's cloud-based licensing. We think that's pretty unique because you get that as standard. So in normal terms, it's a floating license. Usually you can have a lot license or you can have a floating license. Altair have taken a different approach where you have a floating license as standard, which we think is great because a lot of the time you do end up having to pay more for a floating license, and I think it does give you that flexibility in terms of multiple people having the software installed, and it's done on an annual subscription basis. So again, hopefully there's a lower initial investment there for you to hopefully prove the business case, and we're pretty confident that after 6 months you'll be getting a return on investment and you'll want to keep using it. I think we alluded to it briefly. I know we're here today to talk about injection molding. I get that, but remember this is part of quite a holistic product suite, which does actually include other products as well. You know, around you know, FEA. We've got some casting stuff, some metal forming stuff, some extrusion products, and it's all part of that suite. So again, you know, if you are a team that's doing lots of different things and actually investing in an annual subscription and being able to get all of that, offers, we think, great value for money. And for those that might have different use cases that they want to explore, again, we'd be happy to speak to you and to see which product might fit. So I think with that, we've got no more questions coming in. Scheduled for an hour, so we can give you some time back there. Obviously, if you've got questions, drop us an email, and we will be sending a recording out. So if anyone wants to watch it in your team, they can do so on demand. So with that, thank you very much for your time, and we hope to see you on future events soon.
Thank you very much, guys.